now we are ready to start our lecture for today. So our lecture is about safety, electricity safety, and safety in general. Before we start our discussion, let's have a quick, I would say, review for the subject. Safety. It is all about safety. We want always to be safe, whether we are at workspace or we are at home. We need always to be safe. This is something that is a responsibility for everyone to take all the precautions, all the measures needed to keep himself and the team and his family safe. Now, do you think safety, or let's say safe or safety in general, do you think safety is something related to data center only? Do you think the concept of safety is only related to data center? No, so it is about workplace in general. Even at home, safety is everywhere. But when we talk about safety here, we mean safety in workplace, which can be data center, can be any other location. I'm sure that many of you are already employees, maybe you have worked in different locations, maybe including Amazon, maybe the fulfillment centers or other locations. So for sure you worked in areas where you have heavy machinery around you, whether this is a warehouse or whatever. I'm sure you have a lot of risks and hazards around you. And it is required for everyone to know about any risk available in the workspace, know how to deal with that risk, and know how to avoid the risk, or maybe mitigate the risk, or maybe report the risk when needed. In this lecture, we will focus on things that are specific to data center more than any other location, but the same concept applies to any other workspace. Typically in organizations, they ask you to take a training, safety training. And that safety training typically, do you think safety training is something you need to do one time, or something you need to do maybe on monthly basis, yearly basis? Do you think it is one-time training that you need to attend, or it is something that you need to keep attending all the time? Yeah, it should be periodic, and typically companies ask employees to attend safety training every year at least. Sometimes this is by your regulations, sometimes it is by company policy. In my company, we need to attend safety training every year at least once. Now, the details of safety training are different based on your role. So, for example, if you are mainly in office, if you work mainly in office, or maybe at home office or remotely, there are also some safety measures you need to consider, things about your health, about selecting your chair, maybe about monitor time, about keeping some distance to monitors, how to arrange your monitors. So safety is not only about machinery. Sometimes you need to consider some safety even if you are working from home. So if you work in mechanical or in the construction area, you have different safety measures you need to take in place or in mind. Now, if you are in data center, you are in between somehow. You are not really in somewhere which is outside with a lot of construction machines. You are not working in office environment. You are somewhere in between. And you have very special environment that is different than warehouse, that is different than office environment, and also different than home offices. So what are the main risks that you may face in data center? What do you think? What are the safety measures, or let's say the risks? Let's identify the risks and hazards that you face on daily basis in data center. Yeah, arc flash, electrical flash, fire. We discussed fire separately, so we will not discuss it today again. Electricity. Oh yeah, this is a big one, important one. Radiation in data center. Yeah, not mainly. We are not in a nuclear, but you know, electromagnetic radiation is something you need to consider. You are exposed to electromagnetic fields, maybe not that much, not that major thing. Confined spaces, thank you. Yeah, we have confined spaces. Dust, agree. Overloading circuits, maybe also lifting weights. So as data center technician, sometimes you are the one who will install or mount the equipment in the rack. These equipments can be heavy in cases, so you need to apply some safety rules before lifting any heavy weight. Cuts and tools, we have a lot of tools. You need to be careful when dealing with tools. I would say electrical is one of the main risks or areas that you need to consider, and that's why our focus today will be on electrical safety in addition to other safeties. So our lecture today will be divided into 3 sections. One of them is about safety in general. The other one will be mainly about electrical safety. And then we'll talk about grounding and bonding and the concept of dealing with electrical maintenance. Yeah, noise. Yeah, noise is a good one. Data center is noisy. Yeah, this is a good one, actually. When it comes to noise, data centers and servers are noisy compared to warehouse. In warehouse, it is a bit noisy also. But if you work in office environment, maybe you don't face a lot of noise. But in data center, we have high noise that goes beyond the limit of 85 decibel, and this makes it considered some sort of risk area. So we need to consider this. Hazmat, we'll talk about hazmat. So some of these things, yeah, thank you with all what you mentioned. Some of these concepts will be discussed separately. Today is just an introduction about some of the major risks we have. And later we will discuss some of these areas in separate lectures. Overheating, no, yeah, overheating may be in gray area, but if you are in white space, it is actually the other way around. It is really cold. So today we will discuss 3 different subjects. First of all, we will talk about general safety. Now, when we discuss safety, I know that many of you are already aware of these rules, but we need to go over them in this course because some of the guys are new to the field and they need to know about general safety. So this is not different than the general safety rules you have in any workspace. Then we will talk about grounding and bonding, because in many cases you will be the one who will install equipment. You will install electronic equipment that need to connect to electricity. You need to know how to deal with the grounding, how to do bonding for your racks, for your raised floor. We will discuss these concepts today. And then the third part of this lecture today is about electrical safety. What measures you need to take when dealing with electricity, when you want to disconnect electrical circuit for a reason, for maintenance, what extra measures you need to take in mind, and then we'll have the conclusion. So yeah, Logan, we will discuss LOTO today. So these are the things we will discuss today, and I'm happy if you share your experience during the lecture. If you have any experience on any of these subjects we will discuss today. I want it to be interactive because in many cases you guys have a lot of experience in these fields. So at any time, if you have anything to share, please add it in Slack and we can discuss it. Now let's talk about general safety. First of all, let's talk about physical safety, ladder. When you ride a ladder, when you use a ladder for any reason to go up, actually in data center you don't. Maybe you need to use ladder when you lay cables. You know, in data center when you have these racks, typically we have raised the floor, but in many cases we have cable trays that goes above the racks, and in many cases people have the airflow coming from below the ground, below the raised floor. But when it comes to fiber cabling, UTP cabling, other cablings, in many cases they have it in the cable tray. Cable tray sometimes is easier to access. They don't need to open the raised floor. It is easier to organize cables in the cable trays. So I'm sure you have seen a lot of these cable trays in data centers, just to give you an idea what is a cable tray in case you didn't see it before. So if you just Google data center cable tray, we will discuss cabling and cable tray later, but just to give you an idea, these cable trays above the racks are mainly to lay cables. And if you are the one to lay these cables, you will use ladders you need to ride a ladder to go to these high spaces. And you need to deal carefully with ladders. First of all, you need to keep 3-point contact. What does it mean, 3-point contact? It means you should use 3 of your legs, or as you know, every human has 2 feet, 2 legs. So there should be 3 of them at least in contact with ladder at any point. So why 3? Let's discuss physics a little bit. If you have any object, we have gravity. Typically, we represent the object as one gravity. Do you know what we call this arrow, this vector that represents the object for gravity? Do you know what we call it? Yeah, thank you, B. Annie. I want to discuss the triangle compared to a line. So if we have any object, we can represent the gravity as one vector. Do you know what we call this point that represent the mass of the center of gravity? So typically we have center of gravity that push us to the ground, and we have some contacts with the ground. If we have only 2 contacts with the ground, we have only stability line, and our center of gravity should exactly be on that line, which is difficult. So if we have 3 contacts with the ground, we have stability plane. And if our center of gravity within this plane, then we are stable. Now, this is in general, this is physics. The same applies to ladders. If you are using a ladder and you want to go somewhere, and if you have only 2 contacts with the ladder, your 2 feet maybe, there is a good chance that you lose your equilibrium because you need to maintain your center of gravity on that line. If you, for some reason, moved your body around, there's a good chance that you may fall, maybe lose your equilibrium and fall maybe somewhere on the ground, which is an incident or accident we want to avoid. So you always need to keep 3 contacts with the ladder, whether 2 hands and 1 feet, or maybe 2 feet and 1 hand. The idea is that you cannot keep 4 of them on the ladder. How about keeping 4 of them on the ladder? We cannot keep 4 of them on the ladder because we need to climb, and this means we need to move one of our 4 arms or 4 points all the time to move from one area to another. So don't move your 2 legs at the same time, don't 2 feet at the same time, or your 2 hands at the same time. You need to keep one of them at least, one of them moving and the other 3 in contact with the surface, with the ladder. So I think the idea is clear. Yeah, Daniel, yeah, you cannot have lunch on top of the ladder. Now, you can stay in the middle of the ladder. You can face the ladder while climbing up or down. If you are climbing a ladder, you should have a cone or a barricade just to make sure that others are not accidentally bumping into the ladder and cause an accident to you. The ladder should be placed on surface, and this is maybe a challenge a little bit. The ladder has, how many contacts the ladder has? The ladder has 4 of them. So sometimes if the surface is not flat, maybe the ladder will not be stable. You need to make sure that the ladder is stable on 4 contacts before you climb the ladder. Now, this is something that is a bit challenging. If you have 3 contacts with the ground, it is easier to maintain flat. If you have 4, you need to make sure that the ground is flat before you climb. So these rules are general rules, but they matter actually. And sometimes if you don't follow the rules, you may fall actually, unfortunately. If you are for data center cabling, you need to climb the ladder, and you need to stay for a long time maybe. So better to have a platform ladder where you can place maybe some of the tools, maybe you can place your cable ties. So this is something to consider for the data center, to have a platform ladder where you can place some tools. Let's see some photos just to make sure the idea is clear to everyone. So yeah, so this is this link has some of the rules, general rules. I would say these rules are clear and make sense, but just to make sure, 3-point contact to avoid slipping. You have greater control. Make sure the ladder is reliable. Position the ladder properly to make sure it is stable on the 4 contacts. Make sure that the ladder has some distance to the wall. Always 3 point of contact. Avoid moving. Now 3 point of contact is needed, but also your center of gravity should fall within the plane of balance for the ladder. If your center of gravity at any point fall beyond the plane of stability for the ladder, also this may cause an accident and you may fall. So keep in mind always that your center of gravity should be between the contact points of the ladder and contact points of you on the ladder. This way you make sure that you are always in the safe side. If your center of gravity is beyond this plane of stability, then you may lose equilibrium and then you may fall. So yeah, these are the general guidance of the ladder. And I'm pretty sure that these rules are applicable even at home. If you're doing something at home, you need to follow the same rules. Yeah, I agree with you, Logan. So typically three legs are better sometimes than 4 legs because you can easily keep contact with the ground all the time. With 4 legs, the surface should be flat to maintain 4 contacts on the same surface. So it is a challenge. I would say not a challenge, something to consider. 4 contacts are more stable, but you need to make sure that the surface is flat and all of them are stable on the surface before you climb the ladder. This is something that is important if you have 4 points contacts, which is the case here. It gives more stability, but also at the same time, you need to make sure that the surface is flat and you maintain. Yeah, for 4 legs is good as long as the surface is flat. As long as the surface is flat, Stephen, then 4 legs are is a good point. So this is about ladders in general. Just to give you an idea what is a platform. So typically in data center, technicians have something like this. They have platform ladders where they have some area to put some tools maybe or some of the equipment. This is mainly if you are doing cabling. If you need to do cabling and you need to use the cable trays, you need to spend a lot of time doing cabling. You cannot just lay the cable. You need to organize the cables. You need to tie the cables. You need to make sure that the power goes in different track than the UTP cables. This takes time, and you may spend maybe long time, maybe hours on ladder, just moving the ladder around and do the cabling in a proper way. And it is important to keep safety and to consider safety if you are doing cabling work. Enough about cabling. Let's move to heavy equipment. What kind of equipment you may carry in data center? Data center is mainly for servers and network devices. So what do you what is the heaviest device you may carry in data center? Maybe what do you think? Typically, you will not carry the rack. Yeah, I agree with you. Rack is heavy, but typically it will be pieces. Typically, you should not exceed 50 lbs. I agree with you. Servers are heavy. Actually, servers are heavier than network equipment, core switches are heavy. Typically, heavy items are placed in the lower part of the rack. Lighter equipment are placed on the top. Typically, if you have in-rack UPS, in many cases the UPS is central for the whole data center. But sometimes, if you have telecom room that is not protected by UPS, you may have UPS in the same room. UPS and batteries are really heavy. Then people typically have the servers and storage equipment, and then switches at the top of rack switches. If you have core switches, they are heavy. Now, what should you do if you need to carry or to lift heavy equipment? What is the right action to consider? Generators, you will not carry generators. Typically, this will be done by a contractor. You are not the one who will install generators most of the time. You may install network equipment, you may install servers, you may install racks, you may install cables, but not generators. Even the main UPS will not be installed by you most of the time. Typically, you will install equipment in server room only. Yeah, team lift, exactly. So if you have heavy equipment, you need to deal with team, to ask for help, to have to make a team. And there are some machines that can be used to lift heavy servers and hold them in the rack to be mounted, but sometimes they are not available everywhere, are not easy to move. If you need to manually carry or lift heavy equipment, you need to ask for help. Now, how would you know the weight? You need to check the weight before you start the deployment. Don't just take the equipment and go to implement it. You need to read where to find information about the weight for the equipment, about the steps to install the equipment, about the procedure, where to find all that in the manual. So typically, before you go for any deployment, take your time to read. Let me show you an example. So for example, if they ask you to install this switch, don't just take the switch and just plan to install it tomorrow morning. You need to read about the switch specifications. You need to know the weight for the switch. You need to know the physical dimensions for the switch. You need to know the installation procedure. What are the tools needed to install that switch? So all this, the electrical requirements. So you need to read all these, to read data sheet, to read the weight for that switch. The weight should be mentioned here somewhere. Sometimes it is not here, it is in data sheet. So you need to consider reading all the information. Yeah, it is not here, it is in data sheet maybe. So you need to read all the details, and even you need to read the full procedure before you start. Don't start something before knowing the full details about the procedure until the end before you start. I believe UPS will be mainly installed by contractors, not by you. If you have a telecom room where sometimes in normal enterprises or in normal companies, they have telecom rooms, they don't have UPS. So sometimes you need to install rack UPS, and this is really heavy sometimes. If you need to deal with servers are heavier than network equipment. Then, and thank you, Daniel, for sharing this photo. Yeah, sometimes people use some cart or some maybe forklift to just have the equipment. Not forklift, actually, it is some sort of crane to have the equipment in place, and then 2 technicians can mount it. So just make sure to read the procedure, the details before you start the process. Don't be in the middle and then ask for help. You need to ask for help before you start the procedure. So if you want to carry heavy equipment, typically you do need to do it as a team, Omar. So typically you need to ask for help. Even installing one simple switch, it is better to do it as a team, because you need someone to hold the switch, someone to install the cage nuts, another one to screw them, another one to cable them. So always better to have two of you at least. Don't go alone. Sometimes you will get stuck at a certain point and you may hurt yourself. Always ask for help, always work as a team, mainly with dealing with heavy equipment. If you need to carry heavy equipment, make sure not put the pressure or the weight on your knees, not on your back. Ask for assistance always. Prepare very well. Don't go for installation without reading the details, without knowing the weight, the dimensions, the installation procedure, the tools needed for that task before you start the task. Use mechanical lift aids where applicable if you have them available, and use also your PPE equipment. We'll discuss them in more details. And typically, don't lift more than 50 pounds. If you have any, I would say, health circumstances that prevent you from carrying even 50, you need to report this and discuss this with your manager or with your supervisor. The other thing is confined spaces. We have a lot of them in data center. We have the raised floor, we have the false ceiling, we have cabling manholes. So you need to consider precautions when dealing with these areas. They may have low oxygen inside. They might have hazardous atmosphere. They might have include hot and cold aisles. We will discuss them in more details later. And also the ductwork and pipelines. Consider additional precautions when dealing with these locations and consider all the safety measures. Now, how long? Just give you an idea. When you want to install an equipment, let's say you want to install a server. When you order the server, the physical server from the company, there is something called lead time, which means they will never deliver the equipment in the same day or next day. Typically, they need lead time. In most cases, the lead time means the time from you place the order until you receive your product. This is called lead time, the time between ordering the physical equipment to the time it arrives. This is called lead time. Typically, this time is in weeks, at minimum 4 to 6 weeks. Now, in some cases, you may receive it in days. If you order it from a company and company has it in stock, they may have it in stock. But even if they have it in stock, they will not deliver it the next day. There is order processing, which takes a few days. So you typically have a few days before installation. So your manager or your supervisor should do planning once he received the lead time, once he received the ETA, estimated time for arrival. So typically there's something called ETA, estimated time of arrival. So once your manager have this in place, once he knows the estimated time for arrival, he should start planning. He should start asking you to plan your time, to make sure you have the tools. So typically they will give you the part number or the devices that is ordered. Then it is your part to read, to go to the website for the company, read about this product, know the weight for the product, know the power requirements, know the dimensions, the tools needed. You need to plan all this beforehand. You cannot just go and install it the next day. Typically, you need to have few days preparation. There is no golden rule. Different companies have different procedures, but it is your responsibility to make sure you have all the tools, you have all the requirements before you start the process. Don't start and then complain. People will not listen to you if you start the deployment and say, oh, by the way, I discovered I need this tool. Why didn't you inform your manager beforehand? People don't like it typically when you start and then complain. People want you to do planning, to do your due diligence. They expect you before you take the task to verify the requirements before you start the task. You may receive the task, but before you start the deployment, they expect you to do proper planning, to read enough, to know all the details, to have all the tools in place before you start the process of deployment. Does it make sense? Yeah, so there is no direct answer how many days you have, but the most important thing is don't start the task don't start the deployment before you have all the tools, before you are prepared, before you know what you need to complete the task. Okay. Now back to safety, and also this is very general, personal protective equipment, PPE. If you are dealing with any hazardous or even in any, I would say, general workspace or risky environment, you need to have your protection gear ready in place. So this is the first lesson, I would say. This is our first lesson actually to talk about PPEs. What are PPEs? Okay, can anyone tell me what are the personal protective equipment? Give me examples of equipment you use to protect yourself in workplace. Gloves, for sure. Eyewear, yeah. Goggles, maybe. Earplugs. Shoes, yeah. Shoes are important because you may have falling items or maybe nails. Yeah, cabs in cases. Now, in typical data center where you have only racks and there is no construction at all, if we have only racks, no construction at all, and the floor is clean, you are only installing servers maybe. Which one do you think is the most important? Do you think the Googles or maybe the helmet or maybe the shoes or the earplugs? If we want to have them priority of 1, 2, 3, 4, which one of them is the most important? It is now, helmet is important, but this is a finished data center. All places are well tied. It is not construction. Everything is installed. The cable ties, the cable trays are fixed, stable. So maybe helmet is not the most important in some cases if everything is finished. Now, there are cases where you are installing equipment in data center that is under construction. And in this case, the helmet is the most important piece. But in many cases, if the data center is finished and everything is stable, everything is connected in a proper way, maybe the shoes are important, maybe one of the most important items if you are installing, and also the earplugs. So why shoes are important? If you don't have falling items and you don't have any sharp items on the ground, why shoes are important? Yeah, thank you, Emmanuel. Electrical shock is one of the main, I would say, risks in data center. When you are installing servers and equipment, you need to deal with electricity, and having non-conductive shoes, non-conductive gloves are important to avoid any electrical shock. The earplugs are important because we have high noise in data centers, and this may affect your hearing capabilities. So you need to make sure that you have this in place. Now, shoes are mainly for electricity. If data center is fully completed and there are no falling parts, no sharp items on the ground, maybe the main risk you have is electrical shock more than falling items. It all depends, actually. In some cases, you are installing the servers while the data center is still under construction. You are installing the racks while the construction may be still going on. So you need to have all the helmets, the protective shoes, and maybe goggles, everything in place. So it depends. But all of them are important, but the priority depends on the situation. In all cases, you need to check with your organization procedures. You need to check with the local regulations to make sure you follow the rules. Now, in US and Canada, it is the requirement for the employers to ensure the safety of employees, and that's why they need to provide you with the needed or required PPEs based on your workspace or your work environment. This include, but not limited to, the goggles, the safety shoes, helmet in some cases, gloves maybe. And also in data center, we need to consider hearing protection because the noise is really high in data center. Why we have a lot of noise in data center? A good question. You know, why we have high noise in data centers? Is it because of electronics? Electronics, do you think electronics make noise? Cooling, thank you. Yeah, servers, the fans of the servers and the cooling is really noisy. And the servers have fans that are really heavy fans, and the noise for these fans is high. When you have a lot of servers around you, the noise will be really above the threshold of 85, and in many cases, you need to consider earplugs in these cases. So if the noise is above 85 decibel and the technician need to spend some time or long time inside, they need to consider maybe some PPEs. In simple form, they can be just earplugs. You know the earplugs, which are the small pieces that you insert in your ear. Let me show you the earplugs. I'm sure most of you know them, but just to make sure everyone know what we are talking about. Something like this. So at least you need to have these available. Typically, they have a lot of them at the door of the data center. So at the door of the data center, before you enter the server room, typically, before you enter the server room, they have a sign that says this area may exceed the acceptable level of 85 decibel, and you are advised to use these pieces, and then they have them available at the door for you to use if needed. Some employees just avoid them. They say, oh, I'm fine. Some of them, they use them all the time. I would say just use them all the time if needed. Yeah, so you need to have them handy in the center or maybe provide them at the door. Eye and skin protection. Mainly when you deal with fiber, you have an issue more than UTP. Oh yeah, the power supplies, because of the cooling, because power supply typically include fan, and this fan is really noisy. In my office here, I have a switch that I use sometime for lab, and if I run this switch now, you can hear the noise. Let me show you. I will run the switch now, and I will show you the noise. Can you hear the noise? This is only one small switch. Oh, you cannot hear the noise. My mic is good. You know, really, you cannot hear the noise? I can hear it a lot. Oh, I don't know. Maybe I have noise suppression here. But now, because I run one switch only, I need to speak loud to hear myself. And it is only one switch. Okay, anyway, so I wanted to show you something anyway. It doesn't work. So running one switch in my office lab makes me speak loudly because I need to hear myself. So what about if you have tens of these switches around you all over the place? Then it is really noisy. Yeah, I have. It looks like I have noise suppression anyway. Now, what else we have in data center that is unique to data center? We have cables, a lot of cables. Now, the good thing is that UTP cables are easier to deal with, but if you deal with fiber is, there are few risks related to fiber. First of all, how many types of fiber we have? Do you know how many types of fiber we have? Two. We have single mode and multi-mode. We will discuss fiber in more details later, so don't worry, we will discuss them more. But one of the main differences between single mode and multi-mode, what is the main difference when it comes to the type of light inside them? Do you know what is the main difference between single mode and multi-mode when it comes to the light inside them? Yeah, multi-mode is, but it is mainly about single mode use laser. Single mode fiber, which goes for longer distance, use laser. It has single mode, so the laser is one mode, one frequency, one wavelength, let's say, and it moves for longer distance. It is laser inside single mode. In multi-mode, it is LED, which means somehow it is multiple modes on top of each other and they move inside the cable. Single mode is more speed. Single mode is more speed. Single mode is more distance. So single mode is more speed, more distance, single mode, but more expensive also. Multi-mode, shorter distance, less bandwidth, cheaper. They always come together. If you need more speed, more distance, you need to pay more. So yeah, but in all cases, multi-mode is better than UTP. UTP, which is the copper-based cable, it goes for shorter distance. So why I mention this? Because laser is risk by itself. I have seen technicians that sometimes use eye to see if laser is coming from the cable or not, and this is really risky. You should never look at the laser directly by your bare eye. Use Google if needed. Don't look inside a fiber cable. You need to use the tools, the proper tools to verify the cable. And also, the fiber is fiber. It is some sort of glass. Inside the cable, we have some sort of glass. We have cladding, and then we have the core itself, which is glass. So you need to consider extra precautions when you deal with fiber, mainly fiber. So fiber may have laser or LED based on the type of fiber. If you are cutting or trimming fiber cables, you need to consider this, that there are a lot of glass shards around you. They may hurt your skin, or maybe sometimes if you by mistake insert them in your mouth, maybe they may harm you. So you need to consider extra precautions to avoid dealing directly with these glass shards. Also, when you deal with the fiber, you are dealing with laser in single mode fiber, and you are dealing with LEDs in multi-mode fiber. Make sure not to look at them directly. Oh yeah, thank you, Stefan, for sharing this. And also make sure to use the proper tools. Maybe you need to use safety glasses when you deal with fiber. Maybe you need to have certain gloves to make sure that these glass shards don't injure your skin. Maybe it is better to have long sleeve clothing when you deal with fiber or any risky or sharp items. And in some cases, maybe you can even use the helmet if you are in some area or some data center that is under construction. So these are the glasses. Masks are good maybe if you are in some locations where it is dusty, or maybe have some small particles. The hearing assistance maybe, or ear protections. These are things that you need to consider. Just to show you an idea about the fiber and the dealing with fiber, let's see this video. I'm not sharing with sound. Don't worry about sound. But when you deal with fiber, typically you need to have proper equipment. The equipment for fiber are really expensive. Typically, they are not as cheap as UTP. When we deal with UTP, we use crimping tools that are cheap and easy to deal with. But when it comes to fiber, you need to have special tools when you deal with fiber, and you need to have all of them handy. It might be quite interesting for you to understand the difference between. So typically, when they deal with fiber, they use equipment like this. You see the core, which is some sort of glass. It is fiber but glass, and it cut the core. You will find a lot of small pieces around you that may hurt your skin or maybe your eyes. Some people sometimes consider looking at them. I want to show you the with the 3 steps terminating. So some people use these eye techniques to see the light. It is better to use proper tools. There are tools that can measure the signal to verify the laser is coming out of the fiber. But this one is not really the laser. He has a special tool to send light inside the cable, and the light is visible on the other side. This tool. Where was it? Yeah, this tool. He used the tool to push light inside the fiber and then see the fiber on the other side. Now, in many cases, the fiber technicians are considered as high skilled because they need to deal with really delicate fiber. And if you are the one who is terminating fiber, maybe you need to be careful and to consider extra precautions when dealing with fiber. Instead of using the phone, in the video they have special tool to just test the cable. Safety shoes. Now in data center, you need safety shoes mainly for electricity, and also if you are mounting servers, you need to have safety shoes because there is a chance that something heavy drop on your shoes, on your shoes or on your feet. So you need to be careful. A few considerations to keep in mind: it should be comfortable, it should be comfort, it should protect your ankle, it should be durable, it should protect your foot, and also protect your toe. And to be on top of that, it should be non-conductive. It should be an insulator for electricity, because this is the main risk we have in data centers. This video gives you instructions about selecting your shoes when it comes to workspace or safety shoes. So you can just take a look into this video. It is 10 minutes video. So when you have time, just go over the video, go over the instructions. What are the things you need to consider when you select your shoes? I will not run that. You can run it later. You can see the considerations you need to keep in mind when it comes to selecting your shoes. Or maybe if we have time at the end of this lecture, we can go over this video together. But I would say just watch it yourself. So that's it about fiber. On the other side, when you deal with UTP, we use these crimping tools. It is much safer, I would say. Anyone can use the crimping tools, but when it comes to fiber, it needs, I would say, more skilled technicians, more tools than the UTP. UTP, typically, we just follow the steps. We just there are typically two connectors, RJ45 or RJ11. We use typically RJ45 in data centers, and it is easy to do that. You need to be careful also because it has cutting edge here, but I mean, it is less risky than fiber typically. Shielding and shielded. Thank you, Kenneth. We will discuss this in more details later, but UTP is what we use in most cases. Is it cheaper? If we use shielded twisted pair, this is mainly for outdoor or maybe for certain special uses. If you want to have 10 gig maybe for long distance, you use shielded twisted pair. In most cases, we used unshielded twisted pair. We will discuss this in more details later. Unshielded twisted pair is somehow the cables are twisted inside and there is no extra EMF shielding. So this is what we use. It's cheaper and more, I would say, easier to deal with than the shielded. The shielded is only for special uses that we will discuss later when we discuss cabling. Another thing we should have in every workspace or workplace in general is to have emergency plan. In case of emergency, everyone should know exactly what to do. The contact information should be available and visible to everyone. Emergency contact information within the organization or within the data center should be known to everyone. You should know how to report different severity levels. You should know evacuation routes. You should know how to, the company should conduct evacuation drills from time to time to make sure that everyone is ready and everyone practice the steps beforehand. So this is in a brief about general safety. We have two exercises now to make sure that everyone is aware and to participate in this discussion. First of all, I have a question. What should you do if you spot an electrical hazard in the workplace? What should you do? So maybe you saw in data center that we have one rack and then we have one of the cables maybe uncovered, and somehow the conductive is visible for that cable. So what should you do in these cases? First of all, you must report it. Maybe report it to your supervisor, to your manager, or whoever responsible on this facility. Now, correcting this should be done in a proper way. Maybe you are not the one responsible on this. Maybe you have electricians in data center who are dealing with this cable. So it depends who should correct it. It depends on your role. Maybe if you are technician level 1, maybe you are the one who should correct it. But before you correct it, there are certain steps you need to take into consideration. We will discuss them later today. You cannot just come and correct it while the power is running. You need to disconnect power, and disconnecting power needs steps. You cannot do change. You cannot take actions in data center by yourself. Do you know what is the name of the procedure we need to follow when we need to do any change in data center? Do you know what is? There's a name. We call it change management. There is a change management procedure that you need to follow when you want to do any change in data center. Disconnecting the cable is somehow a change. You are bringing the servers down or part of the servers down. You need to follow some change management procedure. You need to say, I want to disconnect the power and maybe direct the traffic to another truck, to another rack maybe. So you need to follow the procedures. You cannot just disconnect the cable by yourself. And it depends on severity. If there is already emergency, if there is a short circuit, maybe you need to take an action immediately. If there is some, it depends on the level actually. There is no single rule that fits all. We need, it depends on severity of the incident and what is the impact if you delay it for 1 hour. But in all cases, you must report it. This is the first thing you need to tell someone who is responsible and discuss with them the next action. If your manager or your advisor suggests starting the correction procedure, and if you are qualified to do this correction procedure, then maybe you can start it yourself. So other than reporting it, what else? Block of area, thank you, good point. You need to inform others. Maybe you need to have some cones or some signs to inform others that there is risk here. After you report it immediately, you start adding the signs maybe. Do you think these steps should be something you come up from your mind when you see the hazard, or maybe there should be a procedure within your organization to tell you exactly how to deal with these situations? There should be a procedure, and you should be aware of the procedure. If you see any hazard, what is the procedure? Do you need to report it first, or maybe you need to notify others to make sure no one fall inside that? So for example, if you have a raised floor, this is very common in data centers. If you have a raised floor and you discover that one of the tiles was removed by someone and the area is open without any sign, maybe the first thing you need to do is to put some signs to notify others so no one fall inside this open tile. Then maybe you need to report it to your manager. So the procedure depends on the internal policies of your organization. Whether to report it first or to put a sign first, there are different opinions. And I would say it comes up to the severity of the situation and the instructions in your organization. Thank you, everyone. Assuming you're authorized, yes, but you don't need to you do need to communicate. I agree with you, Logan. You need to communicate. Now, before disconnecting the power, maybe you need to report it to your manager. You need to inform everyone, and then you need to follow the LOTO. What is LOTO? We will discuss. We will discuss later what is LOTO procedure. We will talk about it later. There should be a safety sheet and there should be a procedure. Okay, thank you, everyone. Now, our next exercise. Now, we will run some sort of PPE scavenger hunt. Try to Google or to search and put in Slack what you find as electrical safety shoes. Try to Google or try to search in the internet for photos for electrical safety shoes, insulated gloves, safety Google, hearing protection, and face shield. Let's start one by one. Who can find electrical safety shoes on the internet and add the photo in the chat? Who is the fastest to get from the internet any photos for electrical safety shoes? Go online, find 3 of the following types of PPE used in data centers, and add the photos in the chat. Thank you, everyone. So as you can see, there are different types of these. Some of the shoes are actually for falling items, some of them for electricity. So when you buy the shoes, you need to make sure that it is labeled, or maybe it is categorized as electrical safety shoes. Now, this is the point. There are different classes, and sometimes you want also the comfort. Some of the safety shoes are designed for mechanical areas, and they are very difficult to deal with inside data center. So maybe in data center, you may consider electrical safety shoes instead of highly rated shoes, because you care about comfort. You are wearing them all the day maybe, and if data center is stable with no falling items at all, maybe you are just doing daily maintenance. You are not doing any installation. You are not mounting any item. You are just doing daily check. So maybe you can have some shoes that are only for electricity. About the gloves, everyone had to choose. Let's say gloves, insulated gloves, because when you deal with electricity, you need to have these sometimes. And also you care about comfort. You want to make sure they are easy to deal with. You can use the screwdriver and other tools while wearing these gloves. How about glasses? Why would we need glasses? What is the main task where you should wear these glasses? What do you think? Which task or which activity of what we discussed today need goggles? Disconnecting power, anything that deal with power is good to have. And fiber, I would say. When you deal with fiber, it is better maybe to have these safety glasses, because when you cut the fiber pieces, they may go around and then touch you. Fiber splicing or fiber termination. Yeah, thank you, Daniel. Now about hearing protection. Hearing protection can be as simple as earplugs, or maybe it can be some earpieces or some sort of headsets that can help you to talk and listen while inside data center. So there are different levels of them. If you want some noise cancellation because you need to listen to instructions, maybe you should have a full headset. If you want only to protect your ears, you don't need to talk to anyone inside. Maybe it is enough to have earplugs inside your ear just to protect. But in this case, you cannot listen to others. You cannot communicate with others while inside. And about face shield. Face shield is needed if you have any small particles, maybe. This is an idea. So this is, thank you all for sharing the information. Now it is time to move to the next item in our list. Thank you all for sharing these photos. So we completed the first part. It is 1 p.m. Let's have um, 15 minutes break, and then we will talk about grounding, bonding, and electrical safety. Any question before we have our break? Okay, break time. See you after. Okay. Okay, everyone, welcome back, and I hope you enjoyed your break. Now it is time to continue with our lecture. Okay. So just to make sure you can see grounding and bonding, and you can hear my voice, you can see my cam. All of them. Yes. Okay. Thank you. Okay. Now we will talk about some electrical safety. But before we talk about electrical safety, we need to discuss the concept of grounding and bonding. We will have a lecture about power systems and electricity later in this course. But as we are talking about safety, we cannot talk about safety without discussing grounding. So what is grounding and why it matters? Before we talk about grounding, let's discuss basic concept of electricity just to make sure everyone know the difference of different items. So in electricity, we have this triangle. Typically, when we talk about electricity, we typically have these triangles. We have V. Do you know what is V when it comes to electricity? What is V? V is voltage, which is somehow the difference in potential between two different objects. So if you have different objects, the V is the voltage, the difference in electrical potential between the two objects. And typically we have the voltage in North America as 110 volt between the neutral and the phase. On the other side, we have I. Do you know what is I? Well, I is current, which is measured in ampere. So I is the current, and current is somehow similar to current of water or fluid. It is somehow the stream of electrons that move inside the cable. We call it the current. So the more the current, the more the current, the more electrons and more energy is passing through the cable, let's say. It is something similar to any fluid, any current of fluids. And what is R? R is resistance. So everybody has some resistance. The human body can conduct electricity, but we have resistance. So our bodies try to resist the electricity. You can think of electricity as stream of electrons, and different objects are resisting this stream. The more the resistance, the current will try to go other path. The current will prefer the path with less resistance. So if we have one object that has high resistance and one object that has low resistance, do you think the current will go to the object through? Do you think the current will go through the object with high resistance or the object with low resistance? Low resistance. So if there's any object with low resistance, the current will prefer to go over that object rather than the object with high resistance. Now we will discuss the other items later when we talk about electricity, but this is the concept. Voltage, current is voltage divided by resistance. So for us, the current is the voltage divided by resistance. If you don't know these concepts, don't worry. We will talk about them in more details later. For me, just I want to discuss the concept of resistance. So what is grounding and why we need it? You know, when it comes to electricity, typically we receive what we call as hotline or phase or positive, let's call it, and neutral. Now, what happens if there is any failure in the device and for any reason the hotline touches the body of the device or the equipment, and the body of the device or the equipment is at high voltage, and for some reason or you touch this surface. Now, for some reason, for any failure in the device, we have high voltage at the surface of the device. And that high voltage has two paths. One path to go through the body of the human, and another path with low resistance that goes through special cable that go to the ground. So we have, in this failure scenario, we have two paths, one through the body of the human, which has high resistance, compared to direct cable that we connect between this device and the ground, and it has low resistance. Which one will be preferred by the current? The ground. So this is the whole idea. We want to ground, we want to connect the surface or the body of electrical devices to the ground. So in case of any failure, the current prefers to go through the ground instead of going through human body. And then we have different ways to discover the failure and to correct it. But at least we want to protect the human. And this way we provide an easy path. We provide low resistance path for the current to flow and to avoid going through human body. The worst scenario for electricity, if you have the current going between your hands, because this will go direct through your heart, which is the worst scenario, or even if you touch the wire by one hand and your leg on the ground, and the path goes through your heart again, this is also a bad situation. How can we avoid the situation where the current goes from your hand to your arm and leg? How can we, in addition to the ground, how can we make sure that the current doesn't flow through your hand, your body, and then through your leg and your feet? In addition, what PPE equipment we can use to avoid this situation? First of all, we want to make sure that the current doesn't prefer to go through your hand, which means what should we add to your hand to avoid this situation? We need to use gloves, and these gloves should be insulated gloves. They are non-conductive material. What else? How about your shoes? Safety shoes. So your shoes should be non-conductive. They should be insulator for electricity. So we make sure that this doesn't go through your body. So we have three measures. We have three different measures to protect you from in this situation. We have three different measures to protect you in this situation. First of all, we have gloves, so the current will never go through your hand. We have safety shoes, so the current, even if you don't have gloves, at least the shoes are, you always wear the shoes 24/7. Whenever you are in data center, you have safety shoes on all the time. So you have another measure, and also we have the ground. So even if you don't have these PPE equipment, the current, the electrical current, will prefer this direct line to the ground instead of going through your body. So this leads us to the subject of grounding. We need to ground electrical components, electrical devices, electrical machines. So in case of any failure or any fault in the device, the current will never flow through your body. It goes through this direct line that has low resistance. It is very conductive material, and the current will always prefer this path against your body. So if there is any excess electricity, it goes through the ground. This excess of electricity happens because of any failure or fault. Typically, the body of the device should not have any electricity. Electricity should be always inside the internal circuits. But in some cases, for any failure or fault in the device, there is a chance that the body or the chassis of that device has excess electricity. We want to make sure that this excess electricity has a way to go to the ground rather than your body. Now, this is one concept. Typically, grounding is used in electrical devices that has active components. So things like maybe machines, generators, electrical machines, even switches, routers, these devices that have active components that carry electricity, they should have grounding to make sure excess electricity has a path to the ground. There is another related concept, which is bonding. Bonding is mainly, we want to make sure all devices in the rack are all connected together. So there is no voltage difference between them. There is no electricity difference between devices in the room. We want to connect, bonding is connecting them together. We want to make sure that the chassis of your switches, your routers, your servers, and also the rack itself, the door of the cabinet, the raised floor, any components in the room are all bonded together. So with this bonding, we make sure the electricity level is the same in all devices in the room. We don't want to have any, I would say, spark or electrical shock or maybe arc flash between these devices, even with short voltage. Something like 19 volt may cause electronic devices to fail. So we want to make sure that all devices in the room, in the server room, are exactly at the same voltage level. There is no difference between them. There is no chance electrical energy or electrical current will flow between these devices because we bonded them all together using conductive devices, and they are all at the same voltage level. So this is mainly for even non-electrical devices. We do this to the rack, we do this to the cabinet door, we do this to the mesh under the raised floor. So non-current carrying devices, non-active devices, we make sure these non-active devices are bonded together, they are connected together, so they represent one voltage level. And then the bonding and grounding can be combined together to connect everything to a common ground, which is the ground of the data center, which is somehow a rod or a plate under the ground that somehow connect all devices to the common ground of the building. Now, in most cases, grounding will be done by specialized electrician who is authorized or licensed to do the grounding of the building. Your responsibility will be mainly to connect devices to this common ground. So this common ground should be there already. That common ground, this common ground for the building should be in place already and should be connected somehow to every electrical source, maybe in the building, somehow to all the outlets. Your role maybe is just to connect, to make sure that all devices, they have three leads or three conductors inside the cable, and one of them goes to this grounding. It is your responsibility to connect the bonding and make sure all devices are connected to the chassis of the rack, and this chassis of the rack is connected to the ground, to the raised floor. And all this is well documented in any installation guide. Any installation guide for any equipment include the instructions for grounding, the instructions for bonding. All these instructions are listed. Yeah, everything has electricity, should be connected to the ground, and anything that is non-electrical carrying should be bonded together. So all conductive components should be connected together to make sure they are at the same potential level, electrical potential level. So there is no surge between them, there is no voltage difference between them. And this is the bonding includes also devices that are not meant to carry current. Like what? Like what devices that are not meant to carry current? Like what? Give me examples of devices. The floor, and also the rack, the cabinet, the rack door, the shelves in the cabinet. All these should be connected together. If they are all connected together, in case of failure, electricity will distribute through all these components. And then typically these bonded systems are at the end connected to the common ground of the building. So we have common ground that make all devices at the same potential level. So this is an example how different devices, these are servers, are connected to common bond or common ground. And typically in any installation guide, you will find instructions how to connect this bond connector. In the back of any switch or router or server, you'll find a place for a screwdriver, for a screw, and also they include a short cable. Typically it will be a yellow cable and with some nut where you screw it to the back, and then on the other side you screw it to the rack, and this way you make sure all these devices are bonded together. I may have some photos. Yeah, again, in the installation guide for Cisco device, installing the chassis, they should include some information about connecting the grounding. So sometimes they call it grounding. It is the same as bonding because at the end, you are bonding this device to the common ground. So typically they have instructions about where to connect it, whether to the mounting kit maybe, or to the back of the chassis. And then they have the instructions of connecting the cable to the chassis, how to screw it. And on the other side, you need to connect it to the rack. Typically on the other side, you connect it to the rack. And this way you make sure that the chassis and the rack at the same voltage. And then this rack is connected to the raised floor connected to all other racks in the center. And you end up having all the devices, whether active or passive in your data center, connected to the same common ground, and there is no voltage difference between them. So in data center, typically we connect all devices to the rack, and then we connect racks to the mesh behind the raised floor. This way we make sure everything is connected to everything. Let's watch this video to make sure we understand bonding. Now, again, you are not the one who will install the common ground for the building. Typically, this should have been installed by licensed electrician as per the rules and regulations in your area. But you are the one who will mount the servers and switches and network equipment, computing equipment, storage equipment, and every one of these devices should be connected, should be bonded to the rack. And if you are installing the rack, you are the one who need to bond the rack to the floor mesh, and also to connect the rack door to the rack chassis. So you are the one who connect the bonding in most of the cases. The grounding should be there, and all your responsibility is mainly to make sure your cables are connecting devices to the common ground. Let's see this video together, and then the idea will be clear. I need to share with sound. Let me share with sound again. Any question about grounding and bonding? These concepts are part of your daily life, mainly bonding. So you need to make sure you understand the process very well. You know, the good thing, most of you are coming from work environment. I'm sure you have done maybe similar things in the past, whether you work as in Amazon fulfillment center or other companies. But if there are people who are new to the market or maybe new to the field, they may need to know this information, and it is always good to refresh and review this information from time to time. Okay, let's watch this video together. It is only 2 minutes. Bonded is a company that manufacture racks. So they explain how to connect the bonding between racks and between devices.
Hi, my name is Brendan Haas. I'm the product manager of grounding and bonding solutions at Panduit. Grounding and bonding can do more than just protect personnel from electric shock. When done properly and intentionally, it can also optimize network performance and protect your equipment. To accomplish these goals, it is best to reference a national or local standard such as TIA 607C and its harmonized global version ISO 30129. Make sure not to only rely on the NEC code. Panduit has devised 5 steps to help address the grounding and bonding network infrastructure in order to make sure that you have the correct products you need. Step 1 is to protect from electrostatic discharge, or equalizing the potential of the worker and the cabinet or the system itself. Electronic circuit board damage can occur with as little as 19 volts potential difference, whereas the electric shock that you feel, hear, or see is up towards 2900 volts. That means
so 19 volt are enough to damage 19 volt difference, the spark that is generated by 19 volt difference as per him is enough to defect or damage electronics. And he mentioned that the typical voltage spark that you see can go up to 2900. He mentioned 2900. So you can see how sensitive are these electronic devices, and that's why we want to make sure everything in the room at the same voltage, the same potential. Now, how about the human body? How to make sure the human body is at the same level? How can we make sure the human body is at the same potential if we want to work on these devices? What do you think? How can we make sure the human body is at the same potential, the same voltage as the equipment before we start installing or touching the equipment? Yeah, we use the RAB, the static discharge RAB. Thank you, Christopher.
you could be damaging 2900 volts. That means you could be damaging the equipment and not even knowing. So to do this, Panduit provides a wrist strap to equalize the worker's potential.
So if all devices are bonded together and with this wrist strap, you are at the same voltage level. So everything at the same voltage level, there is no potential difference. There is no voltage difference between any component, and we don't expect any spark to take place because everything at the same level.
Step 2 is to bond your equipment locally to the cabinet or rack. This should always be done per the manufacturer's instructions, but TIA requires this to be done in a visually verifiable manner. It is easiest to use a green insulated jumper and connect the equipment to a metallic rail strip or horizontal bus bar. If the equipment has metal flanges instead of a landing zone for a 2-hole lug, make sure to use paint-piercing mounting hardware and to bond the flange to the rack or cabinet. Step 3 is to ensure that the cabinet or rack you are bonding to is electrically continuous. Even if there are signs of the frame being welded, you should always use paint-piercing hardware to bond sections together to reduce resistance. Make sure any separate panel or door hinge is also connected with a jumper. Step 4 is to bond this system back to the room's primary or connected with a jumper.
Even the rack door should be connected, should be bonded, should be connected to the rack to make sure they are all at the same voltage level.
Or door hinge is also connected with a jumper. Step 4 is to bond this system back to the room's primary or secondary bonding bus bar. If tapping into a larger run, make sure to use irreversible compression splices and never daisy chain your cabinets or racks together. Step 5 is to bond any nearby conductive items. This means ensuring ladder racks and cable tray sections are electrically continuous, any armored cable is properly bonded, and any exposed building steel and conduit are also connected to the bonding network and back to the bus bar. If you have a supplemental bonding network or below floor reference grid, make sure that either the electrical contractor or a data center technician connects it properly to the support posts as well as to the secondary bonding bus bar.
So everything, even the mesh, is at the same level.
For more information, or if you have any questions.
So this is the concept of bonding, and again, bonding is complementing grounding. So you will do bonding and then everything connected to the common ground of the building. So this way you make sure everything is at the same level without any voltage difference. Okay, so this is about grounding and bonding. So raise the floor, is it part of the story? Yes. Yeah, when we talk about the grounding, how it is important for the safety, the main idea is that with the grounding, we make sure in case of any failure that the current doesn't go through human body. it goes through the grounding cable. And this way we protect the human in case the human doesn't have the PPE. At least we have our own precautions. Now, bonding comes down to raise the floor. Even raise the floor should be connected to the same common voltage, common potential. And this is typically done by data center technician or whoever designed this data center. So it should be in place before you start adding equipment. Typically, the mesh below the raised floor is connected to this bond, and there should be some common bonding point where all devices are connected to this point. So raised floor should also be included. Bonding, grounding should be installed. Proper grounding and bonding is essential for the performance to avoid any fault and any spark that may damage electronic devices. It is also for lightning, for any faulty circuit, any circuit switching, any surge protection. All these failures or faults can be avoided if we use this bonding. Electrostatic discharge, which may damage electronic equipment. Electronic equipment is sensitive to any electric charge. So this way, with bonding, we make sure there is no voltage difference. Now, question. What is the main purpose of grounding in electrical systems? What do you think? Is it to configure network settings, or to duplicate the backup, or to provide path for electric current to flow safely to the earth? Is it A, B, or C? What do you think? Yeah, for sure it is C. Now, before we jump to the next subject, do you have any experience with bonding and grounding? Have you ever done it yourself? Or have you tried it? Or have you seen it in place? Or maybe if you have any unfortunate experience with this concept, where you worked in some location where they did not follow the rules and you had maybe bad incident. Yeah, good. Okay. Now it is time for the last subject of this discussion today. And in this subject, we will talk about electrical safety. Now, as I mentioned, there is another lecture about power systems. In that lecture, we will talk about different power components in data center, how to connect them, how to provide redundancy, how to maintain them, how to do preventive and proactive and reactive maintenance. But in this lecture today, we will focus on safety measures, how to follow the safety procedures when we deal with electrical systems. Yeah, I like it actually, Annabelle, because in most cases, anything related to electricity should be done by licensed electrician. And these are the regulations actually. But what I mean, for you as data center technician, when you mount devices, you need to follow the instructions. So the bonding typically will be done by certified or licensed electricians that know the regulations and the rules. Typically, it is not done by you, but you need to understand the procedure. Your part mainly is when you add any new device to data center. If you are the one to mount the devices in data center, you need to make sure they are bonded to the rack. You need to make sure that the cables are maybe grounded, have the ground lead already connected. So somehow you need to understand the concept, but when it comes to the actual deployment of ground, common ground and bonding, this is somehow some sort of, I would say, skilled and very professional task that should be done by someone licensed and certified for this type of activities. Now, when it comes to electrical safety, there's a good chance that it will be done by someone specialized in electricity, but you need to know the procedure. So when you see the process, you understand exactly what's going on. So in data center, we have a lot of electrical sources and electrical loads. The typical load in data center is mainly servers, electronic devices. And somehow we have also maybe the UPS is considered some sort of maybe charging, or batteries that can be considered also as a load. So we have these electronic devices that are sensitive to electrical shock. And we need to make sure that we have all the factors. You need to have proper training to deal with the devices and to connect them. But in many cases, it should be handled by certified electrician. If you need to deal with equipment, if you are installing servers, if you want to maintain servers, if you want to dismantle servers or switches, if you want to unrack or unmount servers or switches, you need to make sure that the power is disconnected, removed before you do any maintenance. Before you do any repair or replacement, you need to remove power. And typically, this should be done as per the change management. You need to get the approval from your management before you start the process of replacement or repair. Do some visual inspection. Faulty items can be visually visible. So do some visual inspection to make sure everything in place, everything seems to be working properly, or at least physically everything seems to be in a good shape. You need also to test the devices for reliability, make sure they are working, and also you need to make proper testing for electrical devices from time to time. One way to inspect electrical devices is using the heat scanner, because if there is any failure or any fault in electrical devices, they typically generate heat. And this heat should maybe is excessive in certain area, so you know for sure that something is wrong. If you have any cable that is maybe faulty or maybe high resistance cable, you will find a lot of heat around it. So somehow heat is a good way, or maybe an easy way, to identify electrical failures by inspecting the heat using a heat scanner, which is something you need to do on a regular basis. Typically, maybe every day or every few days, part of your daily check maybe is just to run the heat scanner maybe on power devices. And this helps you identify any electrical failure, any faulty items that may cause fire or maybe may cause electrical accidents. So heat is one way to verify the function. So question before we discuss electricity more: what electrical safety hazards are unique to the data center environment compared to other workplace environments? What do you think? What are some of the items that are unique to the data center when it comes to electrical hazard? High voltage equipment, because we have the switchgear, but high voltage equipment are also available in most warehouses or maybe most large facilities. UPS, yeah, I would say UPS because you don't see UPS everywhere. In data center, we want to keep 24/7 power, and to keep it 24/7, we need to have some power storage devices. So power storage is something unique to data centers. We need to store power because we want to provide uninterrupted power. And this power storage can be UPS, can be maybe batteries maybe. So this is unique to data center. And in many cases, these power storage devices are the cause of fire in many cases. I would say they are the main components to fail and to generate excessive heat and to ignite fire actually. Power distribution, yeah, in data center compared to other workplaces, we have a lot of servers which are heavy load maybe. They are distributed all over the place, and we need to have our power extended to all locations. If this was a warehouse, typically in a warehouse, maybe you don't have, you have our shelves, but you don't have power everywhere. You have the power maybe in certain location of the building, but when it comes to data center, we have power distributed all over the place to every rack, and racks actually consume a lot of power, so it is unique in data center compared to other locations. Yeah, on data center, you keep adding and removing devices all the time. You keep adding servers, you keep adding storage, network devices all the time. You keep connecting and disconnecting devices. You do a lot of changes to electrical system in data center because you keep expanding, adding racks. You need to do a lot of maintenance, a lot of expansion, a lot of deployments for electrical systems all the time. It is not one thing you do only one time. Electromagnetic interference, we have high interference. So yeah, these are some of the unique hazards in data center that are not, I would say, not visible or not available in other locations. So how to make sure that your electrical system is healthy and reliable and safe? This is, yeah, I like it, Patrick. So warehouse for electrons. Actually, it is data center. So somehow it is a center for data. Just keep in mind that data is the main component in data center, and data is actually some sort of electrons or magnetic fields based on type of the storage you have. So you need to do some inspection for electrical systems, and basic inspection is enough in many cases. You can detect failures by doing basic inspection on regular basis. So make sure that you verify the electronic equipment, they're functioning as they should be. Make sure you have the tools, make sure the tools you use are functioning, are in a good shape. Make sure the breakers are also working properly. Make sure the space and the cables are connected in a proper way. The power cables are connected. They are distributed between two power strips or the distribution units. So somehow you need to do some inspection, and this is your role as data center technician. Maybe you deal only with certified electricians, but you are the one to report the issue. You are the one who is doing the daily check in data center. You should be able to identify any risk, any hazard. You should be able to identify potential failure in electrical systems and report them to the certified electrician or to your supervisor or manager. Maintenance can be proactive or reactive. You need to have your daily check to make sure devices are not showing any visible, maybe faults or visible damage, and also to maintain your electronic equipment. Servers and switches, they have logs, they have certain monitoring or sensors inside the devices that report all the logs, including electricity, including current level, including voltage level. All these are reported to management system where you can monitor them. So you should have monitoring, maintenance in place, and this is essential for all types of safety, including electrical safety. Make sure moisture, you don't have moisture or humidity. We will discuss cooling systems later. We will discuss the dew point and the humidity and how it affects electronics, but it is something you need to monitor. You need to monitor the environment, the moisture, any spillage, any water around the electronic devices or in server room. This should be monitored and reported. Make sure all the equipment is grounded. When you install devices, make sure you connect the bonding. Make sure all the path to ground from circuit equipment and enclosures are all permanent and continuous. So this is something that you need to inspect as data center technician. You should have the tools to do this maintenance, and your tools should be reliable. Don't use any cheap tools. This is something I would say essential. Everyone knows that if you are dealing with important equipment and expensive equipment, you should always use the proper tool, not only for the equipment, for your safety also. Your safety is more important for sure. So you need to have the proper tools. And as I said before you start any task, you need to make sure you have all the tools. Before you accept the task, before you assign a date for the task, make sure to prepare very well to make sure you have all the tools, make sure you are capable of doing this task, make sure to ask for help or assistance from others if needed before you accept the task and before you schedule the task at certain time. All the tools should be insulated. Everything should be connected to the proper source. Luckily, in North America, we have 110 only, but in data center, you may have 1 phase, 2 phase, 3 phase. Make sure you are connecting the device to the proper power source, whether 1 phase. We will talk about phases later, maybe when we talk about power system. There should be insulation. You should have the PPE all the time. The devices should be approved. You should be trained on the devices. If you are doing fiber termination, you should be trained on using these tools. If you are using any mechanical or electronic device, you should be trained on using the device. You should read the manual and know exactly how this device function. Breakers, you need to monitor the breakers. You need to know how to switch them on or off if needed. They should be labeled to know exactly the function for every breaker and the circuit it serves. All these are important information that should be documented. So if you have circuit breakers, if you are maintaining or monitoring them, maybe you should make sure you know exactly what is on, what is off for these devices. There should be no combustible devices or material near to circuit breakers or near to high voltage equipment. The area should be clear around them. The area about any electrical devices should be clean and dry. I would say these are basics and these guidelines are clear, but sometimes you need to verify them. You need to do checks. You wonder, sometimes people know the rules, but somehow they don't follow the rules. And sometimes you need to do some sort of checklist to make sure the rules are followed and to verify this before you maybe hand over the task or maybe before you mark the task as completed. You need to have some checklist to make sure everything is followed. The area around any electrical high voltage equipment should be clear. There shouldn't be a lot of devices or combustible devices around them. When it comes to cables, whether power cables or sometimes even UTP cables, make sure the cables don't block the walkway or maybe in front of panels. Make sure the cables have proper insulation. If there is any uncovered cables, it should be reported and replaced. The cords are covered, no exposed conductive material. And the area in front of the panel should be clear, minimum 3 feet for workspace. And also make sure the cables have multiple layers of insulation, mainly power cables. So these general guidelines are applicable to data center and also to any other locations, mainly the free space or the clearance around high voltage equipment. It is applicable to data center and also to any other workplace. Now the main part of this section, which is lockout, tagout, LOTO or LOTO. Let's call it LOTO to make it clear. So what is this and why we need it? Let's say you are doing a maintenance. There is some machine or some area of data center where you have faulty equipment and you need to do maintenance on this equipment. So you want to do maintenance on certain electrical device, and this device is connected permanently to the electrical supply. So what you do typically, you go to the circuit where this device is connected and you shut off the circuit breaker, and then you start working on your device. But is this enough? What if someone else is walking in that area and that person found that the circuit breaker is disconnected? So he wondered why the circuit breaker is disconnected, something wrong. So he just tried to volunteer to do something good. He thought he's doing something good and he switched on the circuit breaker while you are working. And suddenly you'll be maybe shocked, or maybe you'll be in a bad accident, I would say. How to avoid this? How to make sure while you are working on the equipment, no one else will, by mistake, power off the circuit breaker or maybe connect the power again. How to avoid this situation? There's an easy concept called LOTO, which means before you do any maintenance on electrical devices, you disconnect the power, you lock it out, and you tag it. So others know for sure that you are working on this device right now. When you tag it, you add information. You add your name, at what time you started, maybe what you are doing, how long this will take. So anyone who see the equipment disconnected, they know for sure that someone is working right now on this equipment. This is the name and contact number for that person, and these are the details of the work they are doing right now. So this is the concept of LOTO. So it includes two parts. First of all, you need to lock to securely disconnect the power and add some physical device to lock the power to make sure no one will connect it again by mistake. But this is not enough. You need also to tag. You need to add a tag with information about the task you are doing, your name, your phone number, how they contact you, how long you expect your repair to take. And then there are boxes. We will see a video that explains the process in more details. So this is a common scenario. You lock it with certain locks, and then you tag it, and you add information here. You add information, your name, how long it will take, at what time you started, how they can contact you, and you add some information about the task you are doing. So anyone who see this, they know for sure that this is not by mistake. Someone is doing work right now, and they should not touch this circuit breaker. Now, before we jump to the discussion, I'd like to show you a short video just to make sure this concept is clear. This concept is important. It saves lives, and it can be a matter of life or death when it comes to this protocol. This protocol can save your life, and it is important to understand it very well. Let's watch this video together and see how this can be applied. It's only 3 minutes, so let's watch it fully.
Lockout Tagout is one of the most important safety concepts in the workplace. Lockout Tagout is the procedure that we use to control hazardous energy during processes like maintenance and inspections. The world we live in is powered by all sorts of energy sources. This energy powers our work.
I don't like their music. Their music is some sort of scary, but anyway, I will run it with their music.
But if this energy isn't controlled, it can be dangerous and even deadly. This becomes especially important during maintenance activities like inspections and repairs. The way to control hazardous energy is by using lockout-tagout procedures. In Lockout Tagout, the lock physically isolates the source of energy to prevent any accidental.
So we have the physical lock that somehow fix the circuit breaker at the off position. This is the lock, and then we have the tag. And the circuit breaker is designed for this lock to be inserted here.
Activation. The tag provides important information. Lockout procedures have tag provide.
The tag is important because whoever watching this should know exactly who is working on this, what they are doing, how to contact them, at what time they started, at what time they will complete the task. So if you forget to remove it, they know how to contact you.
Provides important information. Lockout procedures have 4 basic parts.
4 steps. Remember these 4 steps.
Number 1, identify hazardous energy sources. Number 2, de-energize these sources.
So you need to disconnect.
Number 3, apply locks and tags to prevent unintentional startup during work.
You add the lock and the tag, both. One is not enough. You need to have both. You secure the key.
And number 4, test the system to make sure energy.
Test. It is important to test because maybe by mistake you did not close it properly. Just make sure that this is really shut off and disconnected, and it cannot connect by mistake.
The isolation was successful. This is sometimes referred to as tryout. Then conduct your maintenance work safely. Once the work is finished, make sure you get everyone and all equipment out. Then you may remove the locks and tags and re-energize the system.
Oh, they are simple steps, but they save lives and they are important to follow whenever you do any change or any maintenance on electrical systems. Any question? Now, discussion a question. When it comes to electrical safety protocol, what specific measures should be taken during lockout tagout procedure, and why are these procedures critical for maintaining a safe working environment? If you have any experience with lockout tagout, LOTO, could you please share it? Have you been in any situation where people forgot to follow the procedure and they ended up with an accident maybe? Or do you have any experience in this to share with others? Yeah, in factory, I would say this is more relevant because in factory you have devices connected. Now, one thing to keep in mind, in data center, when we work on servers are connected by power cables to distribution panel. We can disconnect the electricity from here. We have full control. We can unplug the cable. So maybe in many cases, the LOTO procedure is not applicable in data center because the equipment we deal with are somehow controlled by power cords that are visible. We can disconnect the power cord. But in many cases, mainly in factories or if you are touching heavy electrical components, maybe in this case you need to follow LOTO. But if you are dealing with a server or a switch, it is a bit different because switches and servers are connected by power cords where we can disconnect them and we can unplug the power cord. So this is something to keep in mind, that it is not always applicable. In some cases, we have easier ways to achieve the same objective. Oh, really? Incident video. Yeah. So yeah, you see the point. Not always we need it, but if you at any point find yourself in that situation, you know exactly how to do it, and you know exactly the meaning of the tag, and you know how to avoid connecting the circuit again. Yeah. So now let's, this is almost the end. Let's go over some basic safety checks when it comes to electricity. Now, as a data center technician, it is part of your job to do daily checklist sometimes, or daily inspection of servers, of equipment, of power systems. Sometimes you use the heat scanner, sometimes you do visual inspection. So part of your daily checks or frequent checks, you should verify the following. First of all, verify that electrical outlets are all functioning properly. There is no loosen or crack over time on these ones. You need to inspect for any issues and remount or replace as necessary. If you find any outlet that is lousy or cracks, replace it or report it to be replaced. You need to inspect the surge protectors and power strips, or we call them power distribution unit, BDUs. We will talk about BDUs later in this course, power distribution units. Make sure that they are tidy. Make sure you don't daisy chain power strips or BDUs. They are all connected to the source directly. If you have any power cords or cable, make sure that there are no defects like cracks or loose connectors. If you have any electrical systems, make sure they are organized. Never daisy chain. Always connect all power strips and power distribution units to the source. Don't daisy chain one to another. Now, we will talk about some of these concepts later, but the subject of today is mainly safety. So we will keep it about safety. When it comes to power system, we will discuss power in much more details, and we will discuss network and other components later within this course. So this is our maybe second lecture about safety. In the coming weeks, we will discuss, I would say, more deep subjects like networking, like cloud, like IT components. We'll discuss them in more details later. But this is the starting point. We need to talk about safety because safety is essential, and we need to talk about safety before any other component. Okay, now I have one question before we start other discussion. In the lockout tagout procedure, what is the primary purpose of the tag used alongside the lock? Why do we need the tag? Isn't it enough to have the lock and that's it? Why do we need the tag? A, B, C, or D? To indicate the type of maintenance being performed, to serve as a warning that the device or power source should not be activated, to provide instructions on restarting the equipment, to act as visual identifier. Yeah, B. Actually, it is a bit tricky because also A should be somehow mentioned, but the main reason for it is just to make sure that no one will power up the device, no one will activate the device during your repair or maintenance. Yeah, it is this option. Now, second question, which of the following is recommended practice for maintaining safe electrical workplace, especially regarding the space in front of panels or similar equipment? What do you think? Which one of these is the right instruction when it comes to the space about high voltage equipment? Is it maintaining a distance or use cable with multiple layers of insulation? When it comes to the electrical workspace, which one of these is the most relevant one? Cord should be covered, but should be accessible if they disconnect. Now, all of these are instructions, but which one is related to the workspace as a workspace regarding the space in the front? So they want to focus on a space in front of the panel, and this is the one that is related to this. The others are really valid also, but I mean, when it comes to the space in the front of panel, this point is the related one, relevant one. So this is the end of our lecture today, and we still have maybe 10 minutes. I'd like to discuss a subject quickly before we conclude it today. Now, in data center, before we start my other subject, do you have any question about the topic of today? Do you have any question about safety, about electricity? As I mentioned, we'll talk about systems. We'll discuss power systems in more details later. But for the subject of today about safety, do you have anything to add? Any question, any comment? How to check bonding? Good question, actually. I would say, I have never come into this, but I would say maybe short circuit. If you have bonding working, you know, there are many meters that have short circuit check. So if the bonding is working as it should be, if this is your server or this is your, let's say this is your server, and you connected the cable between your server and the chassis, how much do you think the voltage should be between the chassis and the rack? If the bonding is working as it should be, how much should be the voltage between the chassis and the rack? So Logan is correct, it should be 0. What if there is no bonding? If there is no bonding and you put the voltmeter between the chassis and the rack, you will see some floating numbers. I have seen this a lot. I tested sometimes. If you connect between, if you try to measure the voltage between two devices that are not bonded, the voltage will be maybe some low value, or maybe it will be just floating. So you know these devices are not bonded, they are not connected together. If anything other than 0 means these devices are not bonded. So it should be short circuit. And the good thing, you don't need to measure the voltage. Most of the voltmeters have short circuit check. So most of the voltmeters, I don't have my voltmeter handy now, but most of the we call them multimeters. Most of the multimeters, they have specially check to make sure these 2 points are short circuits to each other, to each other, and the voltage is 0 between them. So this is an easy check that you can do if you have the tools. So good question, thank you. Yeah, good question. So if it is not 0, means something wrong. Any other question? Keep the good questions coming. I like this question. Thank you. Now, testing the grounding is difficult because you don't have access to the common ground of the building. It should be done by maybe certified instructor, maybe certified electrician or licensed electrician. Any other question? Yeah, thank you. I did not discuss daisy chaining. Yeah, good point. So daisy chaining means connecting one power extension to another, which is a bad habit. You should never use it even at home. It is bad even at home, not only in data center, even at home. You should avoid daisy chaining because if you have any failure, it will be obvious and it will create failures and hazards. You should never do any daisy chaining. Now, before we conclude it today, I'd like to discuss the data center role. Now, you see that we discuss fire safety, we discuss electrical safety, electrical work. Do you think data center technicians are all at the same level? They do the same tasks, or maybe they have a way to be promoted and to maybe to improve or to proceed with their career path? Do you think all data center technicians are same tier? Or maybe when you start, you will do multiple tasks, and then maybe you'll be more specialized in cybersecurity, maybe in networking, maybe in physical security, maybe in even power systems or electrical systems. Do you think they are all the same, or maybe there are different tiers? How many tiers are typically there? What do you think? Yeah, typically 4. There is no central unit or central organization that sets the names of these tiers, but this is a common, I would say, common practice in the market. Typically, people say data center technicians are classified into 4 tiers. Typically, tier 1 is the starting point. So when you finish this course, I would say most of the time you will be data center technician level 1, but not for sure. Maybe you'll be level 2 or 3. So level 1 is the one who does the equipment installation, the rack and the stack, the cable management, routine maintenance. This is typically done by tier 1 or level 1. So these are the new technicians maybe, or the junior technicians that does all these tasks. And that's why in this course, we want to make sure you know how to do all these tasks. So typically you start as level 1 at the beginning. Oh, the sun is coming to my room, which is good. We had snow for the past 2 weeks. So this is the level 1. Then, but what is next? Next, you'll be more specialized, more promoted maybe. You'll become level 2. At this level, typically you will not do mounting and stacking. Typically, once you are more specialized, they don't want you to do equipment installation. They want you to focus on more advanced tasks. So you'll do more complex tasks like troubleshooting, servers, switches, hardware in general. Maybe you manage the inventory, you have a list of devices added and removed. You'll do the upgrades. Maybe you'll work with vendors, with HPE, with Cisco, with Dell in repairs and troubleshooting. So typically, once you are level 2, maybe you will not do equipment installation. Maybe you will not do rack and stack. You will not do the physical daily checks. Maybe these checks will be done by level 1 technicians, and you will focus more on more advanced tasks. And this is not the end of the story. At certain time, maybe once you become really expert and you know more about networking or servers or certain specialized area, maybe you'll be more specialized. You will do maybe you are a network guy at this time. You will do configuration and optimization for network maybe, or maybe for servers, or maybe for storage. You do the designs. You are the one to monitor scalability. You know when your servers or your data center is reaching the maximum load. You plan properly before you reach the maximum. You add more devices, you scale out, you scale up. So you do all these things. You oversee the security protocols. Maybe you lead the projects, you lead the interaction with vendors. So at this level, for sure, you will not do any of these tasks. You will not do basic troubleshooting. You will be more specialized in one of the areas of data center. And then at level 4, which will be some sort of managerial, at certain level, people became senior enough and they became some sort of managerial position in data center. Sometimes they still do some complex troubleshooting, some complex incidents, security measures, mentoring others. So these are the typical levels. You already gathered to be level 4. Yeah, you know, by the way, you don't need to start at level 1. In this course, you will learn a lot. If you get some certificates, few of them, there's a good chance that you may start with level 2. Maybe you will never do any physical work if you know. Now, I know that we don't do any in-person training in this course. A lot of it, all of it is virtual, but I try to give you the knowledge you need to know, even if this was in person, because they expect you to know how to install equipment. Somehow they expect you to be level 2. You need to understand the process of level 1. You cannot be level 2 doing troubleshooting while you don't know how the servers can be mounted. If you don't understand how the racking and stacking work, you need to understand level 1 tasks to be able to really do level 2. So in this course, if you get enough knowledge, you can visualize all these tasks without doing them yourself. If you add few certificates on top of that, maybe you can start with task 2, maybe with level 2. Level 3 will be difficult. I don't advise even if you have a position as level 3, because you lack the experience of level 2 anyway. Even if you have a lot of certificates, I would say spend some time at level 2 to get the knowledge, then you'll be promoted at level 3 maybe. Not only into networking plus, there are much more certificates. Maybe in one of the coming lectures, if we have time, we will discuss some of the certificates you can get as data center technician, and these certificates help you to start your journey as level 2 instead of starting as level 1.